AI incidents require more than standard response. Prompt injection, model abuse, API breaches, and supply chain compromise all create new evidence trails. In this topic, we'll connect containment, preservation, forensic analysis, and lessons learned into stronger AI security governance. Up to now, you've built the defenses: architecture, identity, guardrails, cloud controls, supply chain security, logging, and SIEA. Now the question changes. When AI threat signals appear, how do we contain, investigate, preserve, and recover? AI incident response follows the familiar lifecycle, but the evidence and response actions expand. Preparation means playbooks for prompt injection, data leakage, model abuse, and supply chain issues. Identification includes prompts, outputs, logs, embeddings, agents, and APIs. Containment may disable endpoints, rotate keys, or isolate retrieval systems. Eradication and recovery can require rebuilding indexes, validating model artifacts, and retesting guardrails. Lessons learned should update controls across security, engineering, legal, privacy, operations, and business owners. One practical way to manage AI incidents is to classify them by where the failure appears. Some begin with identity, stolen keys, over-permissioned accounts, or broken authorization. Others center on data and retrieval, such as leaked embeddings, poisoned documents, or exposed sensitive context. A third group involves model behavior, prompt injection, jailbreaks, misuse, or unsafe output. Infrastructure and ecosystem issues include cloud compromise, insiders, dependencies, and supply chain risk. This taxonomy helps responders find the right evidence, owners, and playbooks quickly. Good AI incident response starts with disciplined triage. First, validate the alert so you do not mobilize around noise. Then classify the event as policy, security, privacy, or continuity related. Severity depends on sensitivity, scale, business impact, evidence of exploitation, and whether the issue is still active. Scope the blast radius across users, prompts, data sources, model endpoints, guardrails, and workloads. Before changing anything, preserve volatile evidence. Then choose the right playbook. If API keys or credentials are exposed, move quickly, but protect the trail. Look for impossible travel, unusual token use, abnormal login patterns, and spikes in model calls. Contain by revoking keys, invalidating sessions, rotating secrets, and requiring step-up authentication. Next, review IAM roles, service principals, OAuth grants, and workload identities. Correlate identity, gateway, vault, SIEM, and cloud logs before deleting or overriding anything. A data leak investigation has two questions: what escaped and why did it escape? Identify whether the exposure involved regulated data, secrets, code, customer records, or intellectual property. Preserve prompts, outputs, retrieval traces, guardrail decisions, and access logs before systems roll them over. Then contain the path by disabling risky features, blocking documents, narrowing RAG scopes, and adding DLP controls. Bring in legal, privacy, compliance, and business owners to assess obligations. In prompt injection or abuse cases, the incident may start with manipulated input, but the real target is application logic. A jailbreak, poisoned document, or indirect instruction can push the model towards unsafe retrieval, tool misuse, or policy bypass. Investigators should trace the full chain: prompts, guardrail decisions, retrieved content, tool calls, and final output. Containment may mean disabling risky tools, removing poisoned content, blocking abusive users, and tightening controls. Detection improves when prompt patterns, retrieval anomalies, and outputs are monitored together. For a suspected AI supply chain incident, assume both the model and its path may be untrusted. Check provenance, hashes, signatures, SBOMs, dependency changes, and training data lineage. Quarantine questionable models, packages, containers, datasets, and pipeline outputs before they spread. Then decide whether to rebuild from known good sources, validate behavior, rescan dependencies, and redeploy only through controlled gates. Finally, review CI/CD logs, registries, repositories, and admin activity for impact. Insider misuse and cloud compromise require a careful assumption. Valid access may be part of the attack. Start by correlating behavior across identity, admin activity, storage, model endpoints, vector databases, and network telemetry. Preserve cloud audit records before making disruptive changes. Then review privileges and contain surgically. Remove risky access, isolate workloads, tighten conditional access, and restrict sensitive AI services. If an employee may be involved, coordinate early with HR, legal, insider risk, cloud security, and executives. Treat containment and eradication as two linked moves. First, contain the active risk. Disable or throttle abused endpoints, agents, plugins, and tool integrations. Revoke keys, rotate secrets, invalidate sessions, and block risky users. Preserve evidence by isolating workloads, containers, pipelines, indexes, and registries. Once stable, eradicate the cause by removing poisoned content, rebuilding affected indexes, patching weak controls, updating retrieval policies, and tuning guardrails before restoring access. In AI forensics, evidence is more than a chat transcript. You need the full operating context: prompts, outputs, model versions, retrieval records, tool traces, access logs, and guardrail decisions. Add platform and cloud evidence, including audit events, admin actions, deployment history, CI/CD logs, and secret access. Preserve before changing endpoints or indexes. Then document custody. Who collected the evidence, when, where it is stored, its hashes, and who accessed it. That integrity makes findings defensible. Once evidence is preserved, the investigation shifts from collection to reconstruction. The goal is to turn scattered signals into one defensible story. How access began, what the attacker did, which controls reacted, what data was touched, and whether persistence remains. For AI systems, that means correlating prompt logs, model outputs, retrieval events, API activity, identity changes, cloud records, and SIEM alerts. The strongest timelines compare guardrail decisions against actual outcomes, so failures and bypasses are clear. Recovery is not the finish line. After every AI incident, run a blameless review that reconstructs the timeline, root cause, business impact, control gaps, and key decisions. Convert the lessons into measurable hardening. Better Sentinel or Splunk detections, stronger DLP and guardrail rules, updated access and data handling policies, and safer architecture. Validate the fixes, train affected users, and get governance sign-off. The goal is simple. Every incident should leave the environment harder to compromise. AI incident response builds on core security discipline, but adds AI-specific evidence and actions. Classify the incident, preserve prompts, outputs, logs, retrieval records, and model versions, then contain with revocation, isolation, rotation, and guardrail tuning. Most importantly, feed lessons learned into governance, assurance, continuity, and stronger AI controls.